One of the more useful pieces of equipment in craning operations is the hydraulic industrial mobile crane. It's used to lift and move heavy and bulky loads, to place loads in hard-to-reach places, and to make efficient use of space. However it's used, it increases productivity. It takes the steady hand of a seasoned operator to make the most of a crane's capabilities. But for all the operator's skill and experience, some of the most important action takes place out here, at the end of the line. Crane operations are a team effort, in which the rigger's duties are a critical counterpart to those of the operator. If a load isn't secured properly, if it shifts while it's suspended, if it exceeds the crane's capacity, or if the sling or load line should break, someone could be injured or killed. Every time you rig a load, your safety and the safety of everyone in the area, as well as the load itself, are in your hands. In addition, equipment worth thousands of dollars may be dangling at the end of that hook. Many crane accidents are the result of a lack of knowledge and plain old carelessness. Knowing how to rig loads properly and applying safe rigging practices can prevent accidents. That's what this program is about. Rigging loads right for mobile crane operations. No one knows when the first crane was devised, but we do know that cranes were used to build the pyramids in Egypt and Stonehenge, the ritual monument on Salisbury Plain, England, more than 5,000 years ago. The ancients learned that it was easier to lift heavy loads by pulling down the line than by pulling up. The designs of cranes have changed through the ages, but the basic operating principles are the same today as they've always been. The laws of physics just don't change. One of the principles the ancients discovered is that they could multiply their efforts by using more than one part of line. A part of line is a section that directly supports the load. In other words, with two parts of line, they could lift twice as much with the same effort. Today, cranes can be rigged into highly complex systems using multiple sheaves or pulleys with a dozen parts of line or more, and with massive motors to do the pulling. The most powerful crane can lift loads up to 6,000 metric tons. For the purposes of this program, we'll focus on relatively simple systems using one or two parts of line. Properly rigging the load is the rigger's job, and it involves several important responsibilities. Knowing the load capacity of the rigging, knowing the crane's lift capacity, understanding the load, including knowing its weight, understanding how to rig and control loads, and knowing the proper crane hand signals. Before you begin any rigging job, be sure to properly equip for it. Wearing the right personal protective equipment is just common sense. If you're hurt because you're not wearing your hard hat, gloves, steel-toed work shoes, or any other safety attire you might need, you can't blame it on the equipment. The first step in rigging any load is being sure the sling can handle the job. Federal workplace rules say that all slings, fastenings, and attachments must be inspected each day before they're used. The most common slings include synthetic strapping, chain, and wire rope. It's the rigger's responsibility to know the capacity of all lifting devices. By law, all lifting chain and web strapping must be labeled or tagged with load capacities clearly identified. Be sure the load or rigging does not exceed the sling's capacity. Also check the capacity of any hardware the sling will be attached to, including hooks, shackles, rings, and tackle blocks. Periodic inspections and written logs are required for all lifting chains, and they're strongly recommended for all other types of slings. Keeping the records accurate and up to date not only keeps you an employer in compliance with the law, it helps identify problems early so you can take action and prevent accidents. Plan ahead so you always have replacements available for worn or damaged equipment. If your slings look like any of these and you have to wait for replacements, you may as well shut down crane operations until they arrive. Chain that's used for lifting must be grade 8 or 10 alloy steel. Most manufacturers identify identify grade 8 chain with the number 8 or 80 and grade 10 with the number 10 or 100. But whatever method the manufacturer uses, just be sure it's marked to indicate at least grade 8 or 10 alloy steel. Also, keep this in mind. Chain used for cargo or vehicle tie-down and transport is designed and rated differently than chain designed for lifting. If you have any questions, check with your rigging equipment supplier to be sure you're using the right kind of chain. When you inspect a chain sling, look for stretched, bent, cracked, worn, or broken links. These are all signs that the chain no longer has its original strength. If a chain is damaged in any way, don't use it. Your life and the lives of other people are at stake. Inspect synthetic webbing in a similar way. Look for cuts, tears, fraying, signs of abrasion. Other warning signs include strapping that's been stretched out of shape or has broken stitches, burns, or holes. Wire rope with frayed or broken wires, cuts, gouges, permanent kinks, or rope that's been crushed or corroded can't be trusted to load. Again, don't use it. It's just not worth the risk. Never use a sling with a knot in it. A little knot in a sling can reduce lift capacity by at least 50%. Knots are unpredictable. Don't forget to inspect the shackles, rings, and hooks. A worn shackle, a stretched, cracked, or twisted hook, or a hook with a broken or missing safety latch is an open invitation to an accident and costly fines for safety code violations. Here are some examples of equipment that should never be used in a professional rigging job. Chain that's been bolted together, distorted shackles, gouged or cracked shackles, bails, eyes, or hooks. A hook that's been cut or welded back together. A hook with a stretched throat. A consumer-grade bolt used in place of the original equipment pin and cotter. An abraded wire rope. Permanently kinked rope. Or frayed synthetic sling. Normal wear is to be expected, but if any sling shows signs of structural damage or excessive wear, replace it. It's a lot cheaper to replace a sling than it is for you and your employer to defend against a lawsuit brought by an injured worker or bystander, and you sure don't want to be responsible for anyone getting injured or killed. When inspecting the crane, be sure that the socket, wedge, and pin are in good condition, with no cracks, deformation, wear, or other damage. Check the condition of the wire directly at the socket as well. Many mobile cranes have an anti-two-lock mechanism to prevent overwinding the load line. The trip arm, push rod, and switch must be inspected to assure that they're working properly. Push up on the trip arm to see that the switch moves and returns freely. Be sure that the cable keeper pin is in place in the sheet plate at the end of the boom. Get up on the deck to see the load line bound evenly on the hoist drum and that it's not kinked or crossed over. Visually inspect the load line for broken wires, kinks, crush spots, or any other defects. Be sure that the guide bars are in place and that they move freely. If the wire rope needs to be replaced, follow the manufacturer's procedure for replacement. When you know your equipment is in good working order, you can turn your attention to load. 3 things you'll need to know are the load's weight, center of gravity, and the load radius. Sometimes you'll know load's weight, but when you don't, you'll have to calculate or estimate it. One common method is to take measurements and use reference materials such as the Rigger's Reference Card or the Rigging Fundamentals Handbook published by Crane Safety Associates of America. Manufacturers and suppliers of steel and other commodities, as well as rigging equipment, also provide materials to help you calculate load weights. If you don't have these kinds of reference materials, talk to your supervisor or contact the manufacturer or distributor to see how to get them. An easy method of determining load weight is by using a dynamometer or load movement indicator. Some load movement indicators provide a warning of near capacity loads or even shut down crane in an overload condition. A third way to estimate load weights is to use your past experience. Compare the load with similar ones you've worked with before. You might even find it useful to keep notes for future reference. Whatever method you use, don't forget to add the down weight or tackle block. The load line has to lift that weight too. When you've established the load's total weight, the next step is to locate its center of gravity. That's the point about which the load is balanced in all directions. The center of gravity is important because it helps determine where and how to attach the sling. Whenever possible, attach the lifting device above the load's center of gravity. Otherwise, the load will be top-heavy and may flip over when it's lifted. It can be hard to locate the CG in odd-shaped load, but here's a good technique you can use. Start by attaching 2 legs of equal length. Then attach a third leg that's adjustable. Adjust the length of the third leg until the load is level. Lifting a load that is not level puts more weight on one leg than the other two. The idea is to distribute the weight evenly, otherwise that overloaded leg could snap and cause others to do the same. To understand why it's important to know a load's radius, try holding a weight close to your body at chest height. Now, extend the weight straight out. It becomes harder to hold. In other words, the further away a load is from its lift point, the more effort required to lift it. This fact is reflected in the crane's load chart. The farther the load is from its lift center, the less weight the crane can safely lift. To find the load's radius, use a tape to measure from the crane's center of rotation to the load line. Measure the distance at the furthest point the load will be handled, whether picking it up or setting it. You and the operator can then use the load chart to determine whether the load is within the crane's safe operating limits. Let's say the load radius is 20 feet. The crane is using the 3-section boom with the outriggers down. If the load weighs 3,000 pounds, this chart shows that it does not exceed the allowable load and can therefore be handled safely. Notice that in this example, it's safe to handle the load only if the crane is operating on outriggers. Its allowable load on rubber is much less than 3,000 pounds. It's important that both the rigger and operator know how to read and understand load charts. Some cranes have the same lift capacities over the side of the machine as they do over the end, but others have much lower capacities over the side. Be sure you refer to the correct columns and rows whenever you use a load chart. Sometimes it may be difficult to measure the load radius. For example, when planning to set an air conditioning unit on a roof. In this case, position the empty hook above destination point. Then check the boom angle indicator and the boom length to calculate the load radius. Another way is to position the empty hook above the destination point. Then swing the boom away from the building without touching any of the other boom controls. Next, lower the hook. Now you can measure the load radius. Securing loads properly starts with the knowledge of the types of hitches you can use, but you also have to know how rigging angles affect the sling's load capacity, how to use various reference materials, and perform some simple math. There are 3 main types of hitches used to secure loads: the single leg hitch, the basket, and the choker. You may see different combinations of these hitches in use, but these are the 3 basic types. The single leg is the most basic hitch. It's good for simple lifting and setting. But if the load has to be transported, it can swing out of control. Always use a tag line to keep loads under control. The basket hitch distributes the load between 2 legs of a sling. The basket hitch is good to use on self-equalizing or self-balancing loads. Don't use a basket hitch on loads that are difficult to balance. Any load that's lopsided can shift and slip out of the sling. The basket hitch has twice the capacity of a single leg hitch, but be careful. That's true only if the leg is vertical. To illustrate, let's say the capacity of this single leg hitch is 1,000 pounds. If you take the same sling and make a true vertical basket hitch, its capacity is 2,000 pounds. It's as if you have 2 single leg hitches. But go from this configuration to this. It's no longer a true vertical basket hitch, and the sling's capacity is no longer twice as much as the single leg. How much the capacity is reduced depends on what's called the horizontal angle. Here's the horizon line. Here's the line of the sling. The angle between them is called the horizontal angle. The smaller or tighter this angle, the more you reduce the capacity of your sling. Just remember, the legs of a sling are not vertical. They have to work harder, and their capacity is reduced. Again, here's the single leg hitch with a capacity of 1,000 pounds, and the basket hitch with a 2,000-pound capacity, or twice as much as the single leg. Note that the horizontal angle is 90 degrees. Now, if you attach the two ends of the sling to a common point, you reduce the horizontal angle. If the horizontal angle is 60 degrees, the sling's capacity drops from 2,000 pounds to 1,700 pounds, or 1.7 times as much as the single leg. This is still 70% greater than the capacity of the single leg hitch, but less than the true basket hitch. With a horizontal angle of 45 degrees, the capacity drops to 1,400 pounds, or 1.4 times as much as the single leg hitch. And at 30 degrees, it drops to 1,000 pounds, or the same as the single leg. Never use a sling at an angle of less than 30 degrees. So remember that this angle, the horizontal angle, is important in determining the sling's load capacity. This summarizes the effect of the horizontal angle on sling capacity. These kinds of charts are very handy for solving rigging problems. If you don't have one, check with supervisor or equipment supplier. You won't always be able to measure the horizontal angle, but here's an easy way to guarantee that it's at 60 degrees. Lay the free length of sling from one pick point to the other. If it's longer than the distance between the two pick points, the angle will be greater than 60 degrees. As we saw, that size will provide a capacity of 107% of a single leg hitch. The last basic hitch is the choke. Because one leg of the sling connects to itself, it can be tightened or choked around the load. It's a simple and convenient hitch, and it can be used on various types of loads. But since it doesn't have full 360-degree contact with the load, don't use it on loads that might slip out. The choker has a maximum of only 75 to 80% the capacity of a single leg hitch, depending on the choke angle. The choke angle is measured from the vertical part of the sling to the point at which the choker end of the sling contacts the load. The thing to remember is, as the choke angle decreases, so does the sling's capacity. The tighter you choke a load, the more you reduce the sling's load capacity, as shown in this table. It's important to note that tightly bending a wire rope sling can reduce its strength up to 50%. Bends in wire rope cause an increase in tension and a decrease in strength. Other types of hitches are variations of the three we've just discussed. Bridle hitches are variations of the single leg hitch. They include 3 and 4 leg slings attached to a common point. The dual leg hitch we saw earlier is also a bridle hitch. The triple leg bridle hitch has 50% more capacity than the dual leg sling, but only if all 3 legs are the same length and the same distance from the center of gravity. In addition, the legs must be adjusted so that each one carries an equal share of the load. The quad leg bridle sling improves load stability, but it often does not provide an increase in lifting capacity. Don't assume that you can take the capacity of one leg and multiply it by the number of legs in the hitch and expect to be able to lift that much weight. With a swinging load, the actual stress on each leg changes constantly, and even with this type of hitch, 2 legs may do most of the lifting, while the others simply help to pass the load. Again, if you're unsure, refer to your rigger's handbook to verify your information. A variation of the basket hitch is the double basket. This is where 2 basket hitches are used at 2 different pick points. Be sure far enough apart so they provide good balance, but not so far apart that they create small horizontal angles. Remember, the smaller the angle, the greater the tension on the sling. Whenever possible, use the natural contours of the load to keep the legs from sliding together. A double choker is this same configuration using choker hitches. Last but not least are the double wrap basket or choker hitches. This is where the sling is wrapped twice around the load. Notice that one of the wraps provides full 360-degree contact, which improves load handling security. This is often a better choice than the standard choker hitch. Now, here are 5 notes on rigging. First, never reeve a sling from one connector to another. This changes the angle of loading on the hoist fitting and can double the load on the connector and the load. The correct rigging method here is to use 2 slings, each attached to the hoist ring, and a separate pick point. Note that this may cause the load to buckle if not stiff enough to resist forces of angular loading. In a case like this, test the load by lifting it slowly. If it begins to buckle, you may need to use another method to provide support for the center of the load. Second, always use padding to prevent wear or chafing or cutting of slings, especially on sharp corners. Third, when a load is to be carried on the deck of an industrial crane, always detach the hook from the load once it's been placed on the deck. If the load should fall off the deck and the hook still attached, it could tip the crane over. Also, never carry a load on the hook at the same time you have a maximum load on the deck, or vice versa. Anything more than maximum would overload the crane. Fourth, always pay attention to see that you and any bystanders are standing away from the crane whenever the operator lowers the outriggers. The outriggers come down with hydraulic force that can easily crush a safety chute and the foot inside it. And last, in any lifting situation, be sure the rigger and the operator are speaking the same language by using the proper hand signals. Work environments are typically noisy, and any miscommunication can be dangerous. We've covered a lot in this program, and as you might imagine, there's a lot we haven't covered. Rigging loads right takes a lot of know-how, and no single program can cover it all. With more than 5,000 years of crane history, it should come as no surprise. And some of the most important action still take place out here at the end of the line. The rigger's job can be just as important as the operator's. Both positions demand the services of truly professional people.